question 10 from the Systems of Equations sheet. So make a note of that, Systems of Equations. And that was the worksheet we were doing for homework in preparation for the Systems of Equations exam. We were doing question 10. Now, question 10 gives an equation, or rather an expression, I should say. It's not an equation because it doesn't equal anything, which is quite useful for doing this next bit, by the way, and we have to remember this as we go through. And we were asked to make this into the form, so we're going to put this into the form of, and where is it? There it is. A times x plus b squared plus c. And really what all that means is complete the square. So nice and straightforward. Now let's just complete the square then and make it into that form as best we can. So we've got 2x squared minus 4x plus 1. Now I'm going to make it equal to 0. This is not an equation. This does not say y equals. So we're going to have to just bear in mind a couple of things as we go through. So I'll make it equal to 0 because I'm going to subtract 1 from both sides. So I want to deal with this side, make it into a perfect square, and then get everything on the right side back over so I can then deal with it and turn it into this form here. All right, so first things first, I know so I've got a coefficient which is 2. So I'm going to divide everything by 2. I'm going to divide this by 2, and of course this by 2. So 2 divided by 2 leaves me with an x squared. And we're going to have to remember, so this is, remember, 2 times by 2 at the end, yeah? At the end I'll put. So that's at the end. So that's something which we need to bear in mind. All right, so 4 divided by 2 is going to be 2, so it's going to be minus 2x is equal to, and we've got, this is just going to be negative 1/2. All right, so we're going to take the coefficient of x, which is negative 2, and we're going to divide it by 2 and square it on both sides. So plus minus 2 divided by 2 squared, so plus minus 2 divided by 2 and squared for both sides. So what does all this come to? Well, I can actually do the shortcut at this point and say, right, this is going to equal to, and this is going to be an x here, and whatever this thing is in here, which is basically a negative 1, because negative 2 divided by 2 is negative 1, we're going to ignore the square, we're going to ignore everything else, and we're just going to put minus 1. That's now our perfect square, and that's equal to, this is going to be negative 1/2 plus, well, negative 1 squared is 1. So negative 1, 1 minus half is going to be a half. So this is going to equal, so I've got x minus 1 all squared is equal to 1/2. So I'm going to now subtract a half from both sides, subtract a half from both sides. So this is now equal to 0, but we're not going to even concern ourselves with that at all. So now we've got x minus 1 all squared minus 1/2, and now this thing here comes into play. We're going to now multiply everything by 2, so times by 2. So this is now 2 times that and 2 times that. So this is now going to be 2x minus 1 all squared minus, well, 2 times that is going to be minus 1. So there is the completed square version of this fellow here. And why is that important? Well, it's important because now we can actually start to say, well, where are the coordinates? Where does this sit on the axes? And we can see straight away where it sits. So if I was to draw, for example, a pair of axes and say, well, that's going to be a 0. Well, this is x minus 1. And x minus 1 simply means that we've got something at plus 1. And we know it's plus 1. I'll put a 1 here, because what would x have to be if this were y? If this was going to be y equals, and it's not, but let's imagine it were, well, what would x have to be? Well, x would have to be 1 so that y could be going to be at 0. So that is this bit here. And again, we're only looking at this bit here. We're not worried about the 2 or the minus 1. The 2, by the way, just makes it really steep. The minus 1 drags the whole thing down 1 unit. But we do know it's centered around 1. So here it is. It's going to be centered around 1. It's going to look something like this here. It's going to turn around. Whoops, sorry, you can't see that. That's where it's going to be. Now, the 2 just makes it steeper. It just makes it more like this here, yes? And the -1 means the whole thing is no longer there. It's going to be dragged down to this point here. So now it's going to be right down to this point here and looks like that. So that's what the graph actually is going to look like. So we know the vertex is going to be at 1. So the question it asks, it says, where is the question? Here we go. It says 10, it says, hence state the coordinates of the minimum point A. Well, the minimum point is going to be 1 long, comma, -1. So we can say minimum point is equal to 1, comma, -1. And that's the minimum point on the graph. Okay, now the next part of it, it says, can we please, and it says it here we go. It says sorry, too much stuff in the way here. All right, now next bit, it asks us, it says to us, look, we've got the line x minus y plus 4 is 0 intersects with this line here, at points P and Q, and this given that the coordinates of P are 3, 7. By the way, this is completely irrelevant. We don't need to know that P is 3, 7. It's just like, who cares? So what we just need to do is we're just finding Q, yeah? So we know there's 2 points of intersection, but we're interested in finding point Q. So we're not worried about P at all. All right, so let's go ahead and do that. And I'm going to do that in the next video.